Assalamu alaikum. Today, inshallah, we are going to continue our chapter about the global innovation in our course about the global strategic management. Let's continue. We started our topic with the international product life cycle and learn about this approach, introduction of the product, and then the growth stage and the maturity, and then the declining, and then see the importance of the expansion in new markets to uh, survive for the global economies, companies, and we saw the different stages of the product life cycle in the innovation, the foreign production, and the transfer, and the critics that faced this approach. And then we move to the second and important approach in our study about the global research and development network, which is the approach that most of the global companies use these days for their global expansion in new markets, especially these companies that depends on research and development and innovation in their industries. And we talk about an example about a global company like Nestle in the nutrition industry and the benefits and the lessons learned from this strategy that Nestle take in the research and development networks, and we see the benefits and the constraints of this approach and the different types of research centers and also the evolution and three stages of this network. Now we are going to continue about the management, as we said, of the global research and development or the innovative networks requires the adaptation of three main elements: the structure of the organization and the systems, the way of working, and so on, and the people or the culture of the different uh, countries. As we know, the global company work in many different countries and markets, and we have different people, different languages, different cultures, and so on. So this is an effective uh, factor in the process of globalization. So let's start with the first element, which is the structure. The structure aspects of the research and development management relates to the size, specialization, project organization, and performance evaluation. So let's see these four items of structure, each one in details. When we talk about the structure, the size, the large size organization not conducive to communication and flexibility required in research. As we see, some 50% of the international laboratories employed fewer than 50 people only, and 80% fewer than 200 people. As in the case of Nestle, the size of laboratories was between 20 employees and 200 employees. So when a research site employs a bigger number of scientists and technicians, it is usually divided into smaller self-contained specialized units. So the large size organization not more conducive to communication and flexibility required in the research and development process. Second, in the structure, second thing we talk about the specialization. We have the discipline centered and the product or the process of production center. The discipline center applies more to upstream research, and the product center applies more to the development work requiring multidisciplinary teams that work on the many facets of product design, utilization, marketability, and the production. So this is the two approaches in the specialization: the discipline centered approach and the product centered approach. Third, which is more important in the structuring of the management of the research and development. the project organization. The most common arrangement for research and development is the project management structure, in which a project leader is responsible for the planning, budgeting, controlling, and completion of a particular development. So projects can be managed purely locally at the local market and then transferred to other units in the global network. Projects are co-located. This is called co-located. We will talk about these different approaches uh, later in these next slides. Or it can be organized by interdependent tasks distributed across units, which is called multiple location products. And we will see the difference in details in next slides. As mentioned already, co-located projects are likely to be more effective because of the communication constraints examined earlier, but co-location doesn't take advantage of the richness of the global network. So there are three forms of project management design. The first one is the self-contained co-located independent projects. In this type or this form of project management design, only one research unit in the network is responsible for the complete design and development and completion of the product or the process of production. So in this case, communication flow between the engineers, technicians, marketeers, and manufacturers is entirely limited to the research unit located on one side in the network. On the completion of the product or process is transferred to another unit. So in this case, for example, in the case of manufacturing of an engine for a car or any other equipment, a particular unit would be responsible for the whole design of a certain type of this engine. But in the second approach, the integrated distributed projects, in which the several research centers. So in the first one, we have only one research unit. Now we have several research centers, which takes the responsibility of one different interrelated element in the design and creation of product process. We have several research centers. Every research center is responsible for one element of the designing and creating of this product. One center will take care of the combustion chamber, مثلا, for example, in the engine, while another will design the regulation. In such case, the inter-unit communication is maximized, since the researchers will have to exchange a lot of information to make the different parts fit together. The third approach is like a mix between them, the parallel distributed projects. The parallel distributed project, in which a project is still divided between several units, but in such a way that inter-unit communication is limited to only few parameters. So it combines between the characteristics of the two earlier approaches. So in this project style, they divided between several units, but there is communication is limited to only few parameters. In the case of the engine, for example, one unit would be responsible for the combustion chamber, including the regulation, while another would take charge of the compressor system. So there would still be some interdependencies to manage, but fewer than in the previous case. If we take an example for HP, the manufacturer of the printers and many computer facilities, when developing, HP wanted to develop a new printer based on inkjet technology by splitting the work between Vancouver and Singapore. So Vancouver was responsible for the product design and marketing, while Singapore was in charge of the electronics parts design, sourcing, manufacturing design, tooling, and testing. The project, at the first place, was designed as integrated distributed one, demanding a large number of interactions between the two units. the project couldn't be completed in time and was dropped. Again, Singapore unit later obtained permission from the headquarters to develop a printer for Japanese market, adopting another approach, which is the self-contained co-located approach. This attempt was not successful also because the unit didn't benefit from the experience gained in inkjet printer design and marketing in Vancouver. After several years, similar product developments were divided differently. Singapore was put in charge of the printer engines, self-contained key component, while Vancouver of the ergonomic and functional design, which is using the third approach or the parallel distributed projects. The results were successful of this approach because each team could work separately with a minimum of interactions and at the same time maximize their respective skills. So in this approach, each team works separately, but there is also a minimum interaction. Yeah, there is still communication and interaction, but in minimum limits, and at the same time maximizing their respective skills. So as you can see here in this chart, there's in the vertical axis the communication among researchers located at different sites. There's low communication and high communication, and in the horizontal axis we can see the location. There is only one location, single and multiple locations. For this approach, the self-contained project approach, for example, for HP Capricorn model, inkjet for Japan, Singapore developed it entirely, and it was unsuccessful. We have here in this approach a single location and low communication among researchers located at different sites. The another approach, the integrated project, we have here multiple locations and high communication among researchers located at different sites. For example, the HP model of Alex Inkjet, Singapore does sourcing, manufacturing, some design, and Vancouver developed the printer design and marketability, and it was also not successful. But if we look at the upper right side, we can see the third approach, the parallel projects with multiple locations, but with low communication among researchers located at different sites. For example, the HP inkjet development as Singapore developed printer engines and Vancouver developed printer ergonomics, and it was more successful. The fourth element in the structuring of the research and development network, the performance evaluation or the control. The performing the evaluation mechanisms was take various forms depending upon the kind of performance that is it is wished to enhance. We have many criteria, as we can see in this table. The performance, for example, the scientific innovation. This is one of the performance that we want to evaluate. With the measurements of this performance of the scientific innovation, it is measured by the number of patents, the number of publications in research journals, and so on. Also, performance of the commercialization. We can see it's measured by the time to market. The performance of profitability, measured by the research unit as profit center. The performance of the cost, measured by the budgeting targets. The performance of collaboration, measured by the organization of conferences, internal seminars, and the internal presentation of papers, and also the number of publications listed on the internet. This is the structure. So what about the systems of the global research and development network? We can see the effective management of global research and development network calls for the implementation of systems and processes for planning and control and knowledge documentation and dissemination. First, we can see the planning and control, and it consists of orderly definition of research projects and their distribution across units. They have many components like the allocation of resources, including budgeting, also the control of resource utilization, the monitoring of project achievements. It's all about the planning and control. Then we have the knowledge diffusion or separation and or spreading and documentation. Knowledge management is not limited to research and development. As for the global research and development, knowledge diffusion and spreading and documentation are based on seven main mechanisms: people rotation, the conferencing, the databases, the publications, the personal networking, and also the electronic knowledge management platforms. This is the system. Now, the last element in the global and research and development network is the people or the culture. We have four people related practices, particularly conducive to global research and development. There is the temporary assignments as a way for researchers to be familiar with the work of other laboratories and sometimes to be assigned to a marketing team. Training programs, constant travel, and conferences allow the interpersonal exchanges and the inculcation of socialization and an open culture of sharing. This is the temporary assignment. Second, the creation of gatekeepers rules in each laboratory. For example, where the task is to be translate the work from other laboratories into the language of his or her own laboratory. The third is the creation of a small central staff whose role is to ensure a proper diffusion of information and research results. And the fourth is the promoting openness and sharing as an important corporate values. So this is the three elements of the global research and development network: the people and systems and the structure. Let's move to the third part of the international technology transfer. When we talk about the technology transfer, every process of globalization implies some process of technology transfer. During the 60s and 70s, the international technology transfer was considered a critical issue because of the emergence of newly independent countries who aspired to industrialize and demand appropriate and complete transfer of technologies from multinational corporations. And with the increased liberalization of economies, this topic has lost its geopolitical connotations, but still remains a managerial issue when dealing with developing or emerging worlds. So we have many types of technology and technology transfer forms. As we can see, it is summarized in this schedule, the classification of technology. We have the product technology, the process technology, and management technology. When you talk about the product technology, there is a physical forms of technology transfer, like the blueprints or the designs of the product, the formulation, the pictures, the designs, the models, samples, research protocols, lab equipment, databases, and so on. There is also some informational forms of technology transfer, like the product development technology methodologies, the research heuristics, the creative methods, the testing methods, and the data mining. Also, the process of production technology. We have some physical forms of technology transfer, like the plant or the factory layouts, the equipment included in it, the process charts, the process handbooks, and some other forms of informational technology transfer, like the process control, the quality assurance, the maintenance process, and the logistics and supply chain. Finally, the management technology. We have also some physical technology forms of technology transfer, like the handbooks, flow charts, manuals, IT equipment, accounting documents, planning templates, and the other forms of informational technology transfer, like in the marketing management, financial management, strategic planning, human resources management, and project management. So, technology transfer takes place under five main organizational and contractual forms, as we see before, like in the licensing agreements, it's one of the contractual forms, projects as turnkey projects or POT project, etc., technical agreements with joint venture companies or local subsidiaries and partnerships, the joint project sales of equipment, and so on. So the typical issues that technology transfer are two main issues in technology transfer. We have to focus on the appropriateness and the completeness. The appropriateness means when it fits with the local context as a trade-off between state-of-the-art technology requiring a solid infrastructure of human capital against less advanced technology that can be assimilated locally. So, as global companies have often been blamed for transferring old and obsolete technology in order to protect their competitive advantage, but on the other hand, many cases of expensive advanced technologies has also been criticized as resource wasting. For example, when Volkswagen, which is car or automobiles manufacturer, a German uh, company for cars production, set up the first Western factory of modern cars. It's called Santana in China in the early 80s. It would have been difficult to transfer the new models manufactured and sold in Europe at this time. Why? Because of the state of roads in China, the network of available suppliers, the volume involved, and the skill level couldn't have permitted the assimilation of such complex advanced manufacturing systems. But over time, the progressive improvement of local conditions made the transfer of modern technology feasible, and comes the Xiac, the Chinese partner of Volkswagen, later entered a joint venture with General Motors to produce a more advanced model than Santana with a more sophisticated production technology. So this is the appropriateness, the completeness of technology transfer. Complete if recipient of technology is able to perform by itself the product of the transfer. And also non-explicit knowledge often requires a coaching approach for technology which is informational. So the developing countries often regret that global companies restrict their transfer of physical content and limit information transfer to a strict minimum in order to maintain their future bargaining power. Although this interpretation is often too extreme, it is frequently true that engineers in global firms are not fully prepared to cope with the considerations of education and patience that a proper transfer implies. So now we finished these two topics, the Global Research and Development Network and the main elements of it, and also the international technology transfer. Next lesson, inshallah, we are going to complete this chapter about global innovation. We will talk about the global knowledge management systems and the protection of the intellectual property rights. So see you next time, inshallah. Goodbye and good luck.